And let's see. So before I was in APU, I used to teach in Tokyo, and originally I came here, I taught at an American university called Temple University, which is in Tokyo also. It's also in Philadelphia. And then I switched to some other schools. One was called Sophia, and another was called Waseda. And then I came here. So as I said, I've been here for 11 years. And I go to Tokyo frequently because I used to live there for a long time. And also, okay, so the grade for this class is based on your homework and of course the final exam, and we also have a test in our 7th meeting. And also we are going to have a bunch of makeup classes because we're going to miss some classes at the end. Basically all of our December classes we won't be meeting. So we have to have some makeup classes because of that. Okay? So the schedule will be posted, but basically I think it's the 22nd of this month, which is Saturday, and I think the 5th of November, which is also a Saturday, and I think the Saturday after that, or the following Saturday, we have Saturday classes. Okay? So, but because of that, we won't have class in December. Although you might have a little bit of a class in December, like maybe 10 minutes. Okay, I might ask you to do some homework, and you'll have short quizzes, and then you can go. Okay? So, the homework is done online, and we use a system called Cengage, which is, Cengage is the publisher, and the online system is called, what's it called? WebAssign, called WebAssign. And so you have to purchase a license at the co-op, at the bookstore, and then you can log on to WebAssign and do your homework, okay? But you have like a 10-day grace period where you can just log on and start without having purchased the license. But after that, you won't be able to get back on the system until you purchase the license. Okay, so that's for people that aren't sure whether they're going to take this class or not, so they can think about it for 10 days. But if you already are sure that you're going to be taking it, you may as well just get it now. Okay? So we have some homework which is already due. Due in a few days, in about 4 days. Okay? So, but you can start that even without paying. Okay? So I made a short video, actually it's not that short. I made a video which describes all of this, and it's on YouTube. So if you'll go to YouTube right now, why don't you just go to YouTube on your computer. Okay, everybody go to YouTube and look for this. This is my videos. Okay, so just do that right now. Go to YouTube and Insider Miner. Okay, everybody get that? Okay, click up here. Okay, everyone get there? And I'd like you to subscribe to this at least during the course, then you can always unsubscribe later, because I will be putting up videos there. And if you subscribe, I think that you can be alerted that a new video has been uploaded. So I'd like you to subscribe. Okay, so click the button here that says subscribe, at least for now. I guess you have to be, in order for that to work, you have to be logged in. So why don't you log into, does anybody not have a Gmail account? So why don't you log into your Gmail account, and then go to this site again, and subscribe. Okay? Now, if you go to the playlists here, go to the playlists here, and you'll see Business Math 2016 Fall as one of the entries. Okay, it just has one video. So these are other classes that I've taught, and I have different sets of videos for them. In fact, there's even Business Math here, but it only has a few videos, only has 6 videos. Okay, anyway, here, if you go to this one. Okay, welcome everybody. This is, so I'm gonna just play a little bit of this. And this is the WebAssign site. So why don't you go to that right now. You go to WebAssign.com. Okay, so you don't have to watch this. I just wanted to make sure that you knew where this is, because I'll play it right now. You can watch it on my screen. You don't have to watch it on your screen. But on your screen, go to WebAssign.com. WebAssign.com. And I'll play this. For business math, and you want to go to this website. It's called WebAssign. It's WebAssign.com, and you want to click on Login, and then you need to put in your username, and your username is the beginning of your email. So like if my email was, so the beginning of your APU email, like that, then my username would just be before the @ mark. So it would just be that. Now I'm going to use somebody else's because I've already registered. So I'm just going to use somebody else's username as an example, like that. And the institution is ritsamacon.jp. Okay, is everybody following this? Okay, ritsamacon.jp. Okay, and then the password is your student ID. Okay, but you should change the password later. But the password now is your student ID. And your password is your student ID. And you should change that later. You can change it later, but for now, I'll use that. And you click Login. Let's hope that it works. Okay, according to our records, you have not yet redeemed an access code for this class or purchased access online. So you have to do that now. You don't purchase access online, do not do that. It won't work. You'll end up paying double because you have to purchase it through the co-op, through the bookstore. So you can do that. You can go to the bookstore, and then when you've done that, you can enter here, click on this one, and enter the access key. But for now, okay, is anybody not able to log in? People? Okay. That's not good. So let me just repeat. Your username is what? It's your email address, but only the part up until the @ mark. Okay, so like my email is so my username is just this part here. Okay, so that's the username. And then what else do we need? The Ritzmekon, some people don't spell Ritzmekon properly. Was it capital R or small r? Small r. So it was Ritsume. Some people leave out the I. Ritzmekon. .jp. Right? Okay, ritzmekon.jp. And then the password is your student ID. Okay, so it should work. And if it doesn't work, we'll fix it later. So you can still watch the video. Okay? Now, we can also do it this way. Continue my trial period. So you have 13 days to before you have to actually purchase the key. So you click continue, and you get to this. Now, actually, here you see that I've made a bunch of assignments for you. Wait, there's something about that. Doesn't seem quite right. Oh yeah, that's right. Yeah, so do you see this when you log in? You see this screen here? Everyone see it? Okay. Okay, so that's all your homework. So you should be happy that there's about 30 homework assignments. A lot of homework happy that you can see all of these homework assignments, okay? So you have a lot of homework to do. Anybody else having trouble? Okay? All right, don't worry about it. We'll fix it, but just make sure you watch this now. Okay, so you have all this homework here. So this is all the homework for the course. Okay? And you can see, well, let's just go on. You have so many assignments, but here they are. And they are, you can see the due dates as well. Okay? And here there's something called the personal study plan, and you can take advantage of that. So you can go through this as you want. And you can also check out View My Class Insights, which should help you. And you also have access to the text here. You also have up here a calendar. So the calendar tells you over here what's due and when it's due. And you also have communication, which is here. And you can send messages to me via that. So I guess you would click here and send me a message. And you have your grades, which are available here. This person doesn't have any grades because we're just starting. And my assignments are here. Okay? And here's a little bit of an explanation about some of them. In particular, this first one, this assignment is intended to help you become familiar with the WebAssign system. So you want to do that right away because you want to get used to this website, which is where you do your homework. If we click on that, you see that you have these questions here. You can access the questions by going 1, 2, 3. You can click on any of the questions, or you can just scroll down here and look at the questions. So this is all just about how to use the system. This is not about math, just how to use this website. And I want you to do that right away. It says it's due October 15th at 12 p.m. Japan Standard Time. You do need to do this right away. Okay, so the first one says what? It's a multiple choice exercise. Select your response by clicking one of the option buttons. These are called option buttons. To change your answer, click another option button. To have WebAssign grade your answer, click Submit Answer. A mark is displayed to indicate whether your answer was correct. So select the option called "This is the correct answer." So that's this one here. You select that, and you can either save your progress and come back to this later, or you can submit your answer. Let's do the wrong answer and see what happens. Okay, has everybody gotten this far? Okay, why don't you try the first two of these, just to get started. So just try 1 and 2, and submit your answers now. Okay, now, I'm not sure if it's, but it should be actually, that every problem in your homework, you have 5 chances to do each one. Okay, so if you get it wrong, you can do it again, and again, and again, and again, and again. You do it 5 times. Okay? I don't know about this particular assignment, but I think it's true even for this one. Okay? So anyway, why don't you just do number 1 and 2, just to get some practice here. So if you haven't been able to log in, raise your hand. Has anybody not been able to log in yet? Okay, good. All right, so just do this right now. Just do 1 and 2 right now. Go ahead and do it. So you can either submit the answer, or you can just save your progress and then come back to this later. But for now, just submit your answer. Okay, can everyone do it? Any questions? Okay, so the rest of these are just questions, just about how to use WebAssign. Okay, so how to use the different tools. They have some graphing tools, so how to use those graphing tools and so on. So it has nothing to do with the math. It's just how to use WebAssign site. Happens. Submit your answer. And it says it was wrong. Okay. Also, you can, there are notes that you can make, and you can ask your teacher. So I want you to go through this to make sure that you understand how to use these tools at WebAssign. And you can also print the assignment, and you can here get extension. You can request an extension. So if you're late on your assignment, you can request an extension, and you will automatically get that extension, but you will lose 20% of the scores of the, 20% of the answers that you haven't submitted so far. So suppose you did 5 of these, but you didn't finish all of them, and you were late on 6, 7, 8, 9, 10, 11, up to 13. So suppose you didn't finish those, and the assignment has been due, but you want to complete it. You can request an extension. So you can request an extension up here, and you will be granted that extension, but you'll lose 20%. Now I think you can request an extension up to 1 week after the assignment was due, and then you have, I believe, And then 2 times 3 is what? 6. Subtract 1. Bring down to 0. 3 into 10 is what? 3. That's 2.3. 3 times 3 is what? 9. I'm sorry. 1, 0. 3 into 10 is what? 3. 3 times 3 is 9. And you can see it's just going to repeat, right? So the answer is going to be what? 2.3333333, right? So 7 thirds is that, right? And that repeats, right? 3333 is repeating, right? So that's repeating. So whenever you have repeating, that means that you can write it as this kind of ratio or rational number, okay? However, it's kind of weird. In fact, there's a story that somebody was murdered because of this fact, because they revealed this fact, that the square root of 2 doesn't have that property. It's not repeating. It's not rational, in other words. It's not rational means you cannot find an A and a B such that it's equal to A over B. Okay? That's what it means to say that it's not rational. Okay, there's no A and B. There's no integer A and integer B that whose ratio equals this. Now, how do you prove that? That's a little bit tricky, but it's not that tricky. But it uses what we call a proof by contradiction. But anyway, it doesn't matter. Anyway, it turns out that this is not rational, and they say that in the time of Pythagoras, that somebody was murdered for revealing the fact that this was not rational, because the Greeks wanted to believe that sort of numbers were all kind of beautiful, and the fact that this is not repeating or that it's not rational was not beautiful. Anyway, that's what we mean by rational. Anyway, so it's repeating and not repeating. So the square root of 2 doesn't have repetition. And pi also does not have repetition. Okay, over and over again. Okay, the next thing they talk about is intervals, some subsets. Okay, so I'm not going to go through this. Of the set of real numbers. So the set of real numbers. You can go through this later. But let's see, what else do I have? Anything else? Is all the numbers, and that will also mean. Okay, I also highly suggest that you read the text. For those of you who want to do well, for those of you who want to be confident when you finish this class in mathematics, I suggest that before we cover the material in class, and you'll probably be able to know that by looking at the schedule here, or looking at the calendar here. So before we cover something in class, so you'll know basically what we're going to do next. And what I'm saying in that video is that you should read the text first if you really want to understand this material. So if you read the text first, even if you don't really understand it, you don't have to understand everything in the text before you come to class. Hopefully, when you come to class, that will help. Okay? But if you read, even if you just spend 10 minutes reading sort of skimming the text, it'll really make a big difference in how well you understand what we're doing in class. I suggest that you find that material in the book and read it. That's especially recommended for people who want to become confident in this material and who want to say that they've mastered this material. Okay? Okay, another thing I want to mention is that we're going to have makeup classes. We're probably going to have a makeup class on the 22nd of this month, which is a Saturday. We're probably going to have one on the 5th of November, which is a Saturday. All of them will be on Saturday. We're probably going to have one on the 19th of November. So that's at least three makeup classes. And that will also mean that there'll be a period probably after November 23rd, I believe, when we won't have class for several weeks. But we will have these makeup classes before that. Also, please check the announcements section of the front page, where I'll put some announcement. I put this here today, but I'll try to put other announcements there if I need to. And again, if you want to communicate with me, you can use this here to communicate with me. And furthermore, let's explore the notifications section over here. So that's under communication. So if you click communications, and then you'll see notifications over here. So do that right now. Okay, click communication, and then click notifications. Here. So I suggest that you go and click on notifications and set this up. Remind me by email before an assignment is due. So you can be reminded 24 hours before it's due, and 30 hours before it's due, and 12 hours before it's due, whatever of these you want to check. Notify me by email when my instructor changes a due date. So you should definitely do that, because it's possible I could change a due date, and you would want to know that I've changed. So like if we cover more material than I expect in class, then I'll change a due date for homework. Or if we cover less material in class than I expected, then I'll change a due date. So it's good that you set this up. You should. When I post an announcement, I would suggest you do that. Answers an extension request, well, I probably won't need to do that because it'll be automatically granted to you. But you can still check that. If I send you a message, you might want to check that. And answers and ask your teacher message, you might want to have that there as well. And notification, contact info. So make sure that you have the right email there. You can do this verify there. Okay, so I definitely suggest that you set up the notifications. In terms of help, you can get help here about how to more data mining stuff, like about neural networks, from numbers, algebra, and graphs with WebAssign, which we began to explore. That's due on the 15th. Then on the 22nd, you have all of these to do. Homework with real numbers. So this is just review from your old classes, I guess. Homework with exponents and radicals. Homework solving polynomial equations. Homework for the coordinate plane. Homework functions from numbers, algebra, and graphs. And homework functions and models. So in order to do all of this, which is quite a lot actually, you're going to have to go through the book. So these are associated with the pre-calculus chapter here. So you'll have to read this and then try to do the homework. Okay? Then for October 29th, we have quizzes on some of this, another quiz on some of this, another quiz on this. This is, I call them quizzes, but... Okay, so the quizzes are really just homework. They're just, the way I did it is I'll give you the homework assignment, and then the next week, as a kind of to make you remember, I'll give you a short quiz on it as well. But it's also part of the homework. It's not like a quiz that we do in class. It's just another homework assignment. It's usually much shorter than the original homework assignment. But it's just hopefully spaced out by a week so that you can kind of review it, so it'll kind of stick in your mind. It's more likely to stick in your mind in that case if you review it after you've learned it. Okay? And then the next thing I talk about is, let me close this now and go back to WebAssign. I don't remember my password. That's not good. Why is it? Okay, just 1 second. Let me just look at somebody else's. Okay, so if you look at the home, you click home at the top left. So in the announcements, let's just go through that. So it says subscribe to Insider Miner at YouTube, so hopefully you did that already. Khan Academy videos quiz. So go to that website and you have to, we're going to have a in-class quiz on the material covered up to but not including the section called piecewise functions in our third class, October 22nd, which is Saturday. And then the next announcement is what? In-class quizzes on homework material. you can expect that there will be in-class quizzes on the material covered in homework after the homework is due. So I'm not talking about the Khan Academy stuff, I'm talking about what's in this WebAssign. So after you do some homework, we probably will have an in-class quiz, maybe a 5-minute quiz on that homework after that homework is due. That probably will be before the quiz. I said on the website there's homework and there's quizzes. The homework is due 1 week and then the quiz is due the week after that usually. Probably the quiz in class will be after the homework, but before the, whatever that, anyway, I don't want to say too much because it'll be confusing. Okay, so let's go to the Khan Academy site, because we're also going to use that. How many people have heard of Khan Academy? Oh, good. Some people have heard of it. So the story is that this guy named, I forget it, Salman Khan, I think his name is. He was MIT, I think he was an MIT master's student, and he had a niece who was having trouble in math, and this was about 10 years ago. And he decided to help her, and he did it via Skype. So he was helping her with math. And he would go and write stuff on Skype, and help her. And it seemed like it was going very well. So he decided to kind of make this into a website, and so he did, and it's called Khan Academy. And he's a really great, he's so clear and so easy to understand, and he does everything perfectly. And it's the best site for learning math. He's such a good teacher. And now he's gotten backing from lots of big places like Bill Gates and Microsoft and lots of other places. It's all free, and it's really good. And it's not just math now, there's a lot of other stuff there as well. But for math, he's really, really great. And he even goes as far as some pretty advanced courses, in particular one really great course called linear algebra. Now that has nothing to do with regular algebra, completely different course, but it's a really great course. If you ever have time, it's very important for what I was talking about earlier, data science. It's also very important in all kinds of, like, if you're going to go to graduate school in the United States, most programs these days, no matter what they are, require a lot of math. And that's one course that you really need to have, is linear algebra. And it's really a beautiful, cool course. And it's really great. And he does a really good job with it. He does a great job. There's one other guy on the web who does it in a completely different way. It's fun to do but it's a much harder way to do it than Khan Academy does it. So anyway, let's look at Khan Academy right now. So it's KH Khan. And before we didn't have to log in, but it seems like, oh, anyway, you can just start learning now. I don't think you, no? I guess you can sign up with email or Gmail. So he has these different subjects. So early math, arithmetic, algebra, geometry, trigonometry, statistics, calculus, differential equations, linear algebra, and so on. Then he has lots of other stuff now too: physics, chemistry, biology, electrical engineering, health, computer programming, blah, 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 economics and finance, even music, and blah, 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 all this stuff. But I don't know about all these others, but in math, it's really good. Okay, so I told you to go to algebra. I told you that you're going to have a quiz. It's actually on this section here, functions, under algebra. do some problems, and then more videos, and practice, and more videos, and practice, more videos, practice, more videos, practice. So it's quite a bit, actually. Typical video might be 7 or 8 minutes. Let's see. Let's look at this first one on what is a function.
Put our y's there. When x is 0, y is 1. When x is 2, I'm sorry, this was when x is, a function, and I'm going to speak about it in very abstract terms right now, is something that will take an input. It will take an input, and it'll munch on that input, it'll look at that input, it'll do something to that input, and based on what that input is, it will produce a given output. So what is an example of a function? So I could have something like f of x, and x tends to be the variable most used for an input into the function, and the name of a function tends to be, f tends to be the most used variable, but we'll see that you can use others. But we could have f of x is equal to, let's say, x squared if x is even, and let's say it is equal to x plus 5 if x is odd. So what would happen if we input 2 into this function? And the way that we would denote inputting 2 is that we would want to evaluate f of 2. This is saying let's input 2 into our function f. And everywhere we see this x here, this variable, you can kind of use this as a placeholder, let's replace it with our input. So let's see, if 2 is even, do 2 squared. If 2 is odd, do 2 plus 5. Well, 2 is even, so we're going to do 2 squared. So in this case, f of 2 is going to be 2 squared, or 4. Now, what would f of 3 be? Well, once again, everywhere we see this variable, we'll replace it with our input. We'll replace it with our input. So f of 3. So 3 squared if 3 is even, 3 plus 5 if 3 is odd. Well, 3 is odd, so it's going to be 3 plus 5. It is going to be equal to 8. Now, you might say, okay, that's neat, Sal. This was kind of an interesting way to define a function, a way to kind of munch on these numbers. But, you know, I could have done this with traditional equations in some way, especially if you allowed me to use the squirrely bracket thing. What can a function do that maybe my traditional toolkits might have not been as expressive about? Well, you could even do a function like this. You could have, and let me not use f and x anymore, just to show you that the notation is more general than that. So I could say h of a is equal to the next largest number that starts with the same letter as variable a. It says as variable a, and we're going to assume that we are dealing in English. So given that, what is h of 2 going to be?
What in the world is he talking about? Anybody? What is this? Anybody? I don't even know what he's talking about. Anybody know what he's talking about? The next largest number that starts with the same letter as oh. So it starts with a T? Ah, that's what he means. So 2 starts with a T. So what's the next largest number that starts with a T? So 3. Oh, I guess 3. 3 starts with a T, right? Everyone following me what he's saying? It's kind of weird. No? It's very weird. I don't know where he came up with this example. He said, so h of a, the answer is going to be the next largest number that starts with the same letter as the variable a. I think he meant, okay, well, I think what he means is So 2. So we want to know what h of 2 is, right? So I think what he means is, what letter does 2 begin with? If you spell if you spell out 2, how do you write it in English? T-W-O, right? Right? So what letter does it begin with? T. Right? 2 begins with a T, right? T-W-O, 2. I'm sorry, T-W-O, T. Right? Okay, so what's the next largest number after 2 that also begins with a T? 3, I guess. I think the answer is going to be 3 here, if I understand his rule. Okay, let's see if that's right. I'm not sure if it's right, but I think that's what he means.
Well, 2 starts with a T.
Right,
What's the
right.
next largest number that starts with a T? Well, it's going to be equal to 3. Now, what would h of, I don't know, let's think about this. What would h of 8 be equal to?
Okay, what's the h of 8? So 8 begins with what in English? E, right? Right? E-I-G-H-T, right? Okay, so what's the next largest number that begins with an E? What is it? What? 11, right? Okay, I think it's 11, right? Okay, let's see.
Well, 8 starts with an E. The next largest number that starts with an E, so it's not 9, 10, it would be 11. And so now you see it's a very, very, very general tool. This function is, this h function that we just defined, we'll look at it, we'll look at the letter that the number starts with in English, and so it's doing this really, 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 really wacky thing. Now, not all functions have to be this wacky. In fact, you have already been dealing with functions. You have seen things like y is equal to x plus 1. This can be viewed as a function. We could write this as y is a function of x, which is equal to x plus 1. If you give as an input, so let me write it this way. So for example, when x is 0, we could say f of 0 is equal to, well, you take 0, you add 1, it's equal to 1. F of 2 is equal to 2. You've already done this before. You've done things where you said, look, let me make a table of x, let me take and put our y's there. When x is 0, y is 1. When x is 2, I'm sorry, this was when x is, I made a little mistake, where f of 2 is equal to 3. And you've done this before with tables where you say, look, x and y, when x is 0, y is 1. When x is 2, y is 3. So this, you might say, well, what was the whole point of using the function notation here to say f of x is equal to x plus 1? And the whole point is to think in these more general terms. For something like this, you didn't really have to introduce function notations, but it doesn't hurt to introduce function notations because it makes it very clear that a function takes an input, takes my x, and this definition, it munches on it. It says, okay, x plus 1, and then it produces one more than it. So here, whatever the input is, the output is one more than that original function. Now I know what you're asking. All right, well, what is not a function then? Well, remember, we said a function is something that takes an input and produces only one possible output for that given.
Okay, so did everybody get this Khan Academy? Okay, so I'm going to ask you to go through this section on functions. Okay? Now, it's something that we also cover in our class, but he's going to spend more time, I guess, than we will. And so anyway, I'm going to ask you to do that, and then I'm going to give you a quiz on this. And the quiz is going to come from the homework problems that are in this Khan Academy. Okay, I showed you that there are homework there are exercises that he has in here. By the way, there's also a transcript here, so he has the whole thing there. Okay. Okay, so this is a very great site. Now, let's just see, I don't think this is a good idea to do this, but let's see what he does with linear algebra. Just curious how quickly it becomes too difficult. for us. Essence of linear algebra. Let's see what he says. Essence of linear algebra preview. There's hardly any theory which is more elementary than linear algebra, in spite of the fact that generations of professors and textbook writers have obscured its simplicity and by preposterous calculations with matrices. I'm not so sure about that. Anyway.
Hey everyone! So I'm pretty excited about the next sequence of videos that I'm doing. They'll be about linear algebra, which, as a lot of you know, is one of those subjects that's required knowledge for just about any technical discipline. But it's also, I've noticed, generally poorly understood by students taking it for the first time. A student might go through a class and learn how to compute lots of things, like matrix multiplication, or the determinant, or cross products, which use the determinant, or eigenvalues. But they might come out without really understanding why matrix multiplication is defined the way that it is, why the cross product has anything to do with the determinant, or what an eigenvalue really represents. Oftentimes, students end up well practiced in the numerical operations of matrices, but are only vaguely aware of the geometric intuitions underlying it all. But there's a fundamental difference between understanding linear algebra on a numeric level and understanding it on a geometric level. Each has its place, but roughly speaking, the geometric understanding is what lets you judge what tools to use to solve specific problems, feel why they work, and know how to interpret the results.
Not very clear. Anyway, this is not him. He does also. Wait, this is not Khan. Let's see.
Hey everyone! No. If I had to choose just as a linear algebra start to click, and which two...
This is not him. I wonder what happened to his class. Linear algebra. What happened? He had such a good one.
A vector is something that has both magnitude and...
That's it. Okay, anyway, somewhere in here it's his. I don't know what that other stuff was. But how about this? How many people have heard of vectors before? Vectors. Okay, let's see what he says about vectors. What is a vector? Can anybody remember what a vector is? Well, we usually picture a vector with what? An arrow, right? So there's two things that are important about that arrow. What are they? Two things. One is how long it is, and the other thing is what?
Direction.
The direction, right? So vector is used to, when you want to talk about something that has a magnitude or a size, and also a direction. So let's see what he says.
And a direction. Magnitude and direction. So let's think of an example of what wouldn't and what would be a vector. So if someone tells you that something is moving at 5 miles per hour, this information by itself is not a vector quantity. It's only specifying a magnitude. It's not, we don't know what direction this thing is moving 5 miles per hour in. So this right over here, which is often referred to as a speed, this is a speed, is not a vector quantity just by itself. This is considered to be a scalar quantity. If we want it to be a vector, we would also have to specify the direction. So for example, someone might say it's moving 5 miles per hour east. So let's say it's moving 5 miles per hour due east. So now this combined 5 miles per hour due east, this is a vector quantity, and now we wouldn't call it speed anymore. We would call it velocity. So velocity is a vector. We're specifying the magnitude 5 miles per hour and the direction east. But how can we actually visualize this? So let's say we're operating in 2 dimensions. And what's neat about linear algebra is obviously a lot of what applies in 2 dimensions will extend to 3, and then even 4, 5, 6, as many dimensions as we want. Our brains have trouble visualizing beyond 3, but what's neat is we can mathematically deal with beyond 3 using linear algebra, and we'll see that in future videos. But let's just go back to our straight traditional 2-dimensional vector right over here. So one way we could represent it as an arrow that is 5 units long. We'll assume that each of our units, our unit here is miles per hour, and that's pointed to the right, where we'll say the right is east. So for example, I could start an arrow right over here, and I could make its length 5. The length of the arrow specifies the magnitude. So 1, 2, 3, 4, 5. And then the direction that the arrow is pointed in specifies its direction. So this right over here could represent visually this vector. If we say that the horizontal axis is, say, east, or the positive horizontal direction is moving in the east, this would be west, that would be north, and then that would be south. Now what's interesting about vectors is that we only care about the magnitude and the direction. We don't necessarily care where we start, where we place it when we think about it visually like this. So for example, this would be the exact same vector, or the equivalent vector, to this. This vector has the same length, so it has the same magnitude, has a length of 5, and its direction is also due east. So these 2 vectors are equivalent. Now one thing that you might say is, well, that's fair enough, but how do we represent it with a little bit more mathematical notation so we don't have to draw it every time and we can start performing operations on it? Well, the typical way, one, if you want a variable to represent a vector, is usually a lowercase letter. If you're publishing a book, you can bold it, but when you're doing it in your notebook, you would typically put a little arrow on top of it. And there's several ways that you could do it. You could literally say, hey, 5 miles per hour east, but that doesn't feel like you can really operate on that easily. The typical way is to specify, if you're in 2 dimensions, to specify 2 numbers that tell you how much is this vector moving in each of these dimensions. So for example, this one only moves in the horizontal dimension, and so we'll put our horizontal dimension first. So you might call this vector 5, 0. It's moving 5, positive 5, in the horizontal direction, and it's not moving at all in the vertical direction. And the notation might change. You might also see notation, and actually in the linear algebra context, it's more typical to write it as a column vector like this, 5, 0. This, once again, the first coordinate represents how much we're moving in the horizontal direction, and the second coordinate represents how much are we moving in the vertical direction. Now this one isn't that interesting. You could have other vectors. You could have a vector that looks like this. It's moving, let's say it's moving 3 in the horizontal direction and positive 4, so 1, 2, 3, 4 in the vertical direction. So
Okay, so anyway, this is not a class in linear algebra, so I just wanted to show you Khan Academy. Okay, but it's really good. He does have other things like stuff in business and so on. Okay, so today, I guess we have to start, even though I can't log into my site for some reason. Okay, why don't we take just a 5-minute break, and then I'll see if I can log in. If I can't, we will do a little bit more. Okay, so how do we do this? Let's go from, let's see, how do we do this? Open student view or question browser. That's the easiest way to preview the assignment. Okay, here. Okay, this has the answers in it. So what's the first one? So here we have this, looks like a kind of a table, right? What's the top row? Starts with what? X. What's the bottom row? F of x. So this is defining a function. So it tells you that when x is -3, f of x is what? 2. Okay, can everyone see that? When x is -2, f of x is what? 2. So what's f of -1? 6, right? What's f of 1? 2. Okay? Now, by the way, you have watch it here. And I didn't show you, but in the video I show you that in the book, they also have videos. So you'll see a little video mark, and there, you click on that, and there's a video associated with the section. Okay? And if you watch my video, you'll see that actually, that I show you that in the video. But anyway, so what's this? So you can play this video? Maybe? Maybe not? Well, it should work, but right now it's not working. I don't know why. Oh, here, okay.
Evaluate or estimate each expression based on the following table. And we're given a table of values for x and a table of values for the function of x. And here we're given the function of -1. So going along this table and finding in the x row -1, we then go down to the f of x row, function of x, and find that that corresponds to 4. So the function of -1 in this case is equal to 4.
Okay, so there are some videos. Not every problem has a video, but okay, this is the same thing, except that here they say, figure out what f of 1 is, figure out what f of -1 is, and then subtract those values and say what that is. Okay? Okay, how about this one? If a is equal to 15, that means what's the coordinates of this point? Is that right? Did I do that wrong? 2, 3? Yeah, that's right, right? Why are you looking at me like I did it wrong? That's right, right? Everyone agree? Okay, so what do I get when I finish that off? 9 plus 12. Right? 4 times 3 is 12. So what is that? Okay, so this gives me that, right? Okay, everyone understand? Not that complicated, just convenient. Right? It's like a convenient way to write this, right? Okay, and so this function we'll call h, this function we'll call f, g, p, and q. Okay? So these are all examples of functions. For example, f of 5 is what? Means what? I substitute 5 here, so I substitute 5 here. So what do we get? 25. Okay? And how do I read this? In English? We read it f of x equals x squared. So everybody say it together. F of x equals x squared. Okay, let's try g. How do we read it? G of x equals x plus 8. And one more. P of x equals x squared plus 3x minus 7. Okay, what's g of 10? What's g of 10? Means I'm putting 10 into g. So what do we get? 18, right? Okay, everybody get this? Okay, so these are examples of what we call functions. Okay, now, okay, yes? Okay, so how about, so this is a function, but we also talk about the graph of a function. The graph of a function, this is not really a graph, it's just a function. To talk about the graph of it, we have to say, graphs, we need two variables, right? Because graphs mean something that we draw in here, right? So graphs need an x variable and a y variable, but there is no y variable, it's just this. So if we're going to talk about the graph of it, we're going to say we mean this. Okay, so that's what we mean by the graph of the function. We mean this kind of thing. If I want to know the graph of this function, I mean this. So if I want to know the graph of this, that's not that hard to write, to draw. The graph of y equals x plus 8 should not be a big problem for you. Okay, what is it? Is it a curve or a straight line? It's a straight line, right? And straight lines have slopes, and we also usually ask where they cut the y-axis. Right? They have slopes, and we also talk about where they cut the y-axis. Where they cut the y-axis is called in English what? The y-intercept. That's what it's called in English, the y-intercept. Okay, that just means where does it cut the y-axis? So does it cut it here? Does it cut it here? Does it cut it, where does it cut it? Right? And the slope, I think you know what the slope means. Okay, the slope means something that has a big slope means it rises quickly, and something that has a small slope rises slowly. So for example, this line has one kind of slope, whereas this line has less of a slope. Okay, because it rises less quickly. Okay, so when we talk about a line, we talk about where does it cross the axis, the y-axis, and what is the slope. So how about, you already told me that this is a line, so the things I'd like to know about the line are what? Where does it cross the y-axis and the slope. So does anybody know those things? Where does it cross the y-axis? At 8. At 8. And what's the slope? 1. Right? The slope is what multiplies that, which happens to be 1 for this. Okay? So anyway, that's this. This is a line, but I said this without the y is the function. But if you want to talk about the graph of the function, it means asking if you said the function equals y, what kind of picture would you get? Okay? So what about the graph of f? Is that going to be a straight line? Is that going to be a straight line? That means that we're talking about what when we talk about the graph of f? We mean the graph of this, right? And I think you know that that's not a straight line, right? In English, that's called a parabola. Okay? Does that ever go below does that ever go below the x-axis? No, it's always positive, right? It's always positive, and it looks like something like that, right? Doesn't go below the y-axis, the x-axis, but okay? So that would be the graph of this function. All right, so we can talk about functions, and we can talk about their graphs. Okay? Now, okay, but what is a function? So we have examples, but I want to define function. So I remember in like 7th or 8th grade, my teacher told me that this wasn't what we mean by a function. That's a function. That might be the function f. Or if this is the function f, then what do I mean? Well, f was what? Right? So what that means is that if I put in 3, that means I substitute 3 for x. X is called the input variable, and y is called the output variable. So we're talking about this. So x is called the input variable, and y is called the output variable. So if I put in 3 for x, then what, and I do the function, then what do I get out? 9. Okay, so that's a function. Okay? But another way to define a function is to say that it's a, to say that it's a set of ordered pairs. What the hell does that mean? A set of ordered pairs. That's a very, first of all, what does that even mean? Let's read it backwards. Because in English, a lot of times, the main thing is on the right, and then we have modifiers to describe it, right? So you have like a subject, and then you have an adjective here, an adjective here, an adjective here. So they're all modifying this. So the main thing is sitting here, right, in an English sentence sometimes, right? So this is what? Pairs. So what does pair mean? Pair means 2, right? Okay, what do we mean by ordered pairs? Well, when I tell you this point, what are the coordinates of that point? 3, 2. Is that the same thing as 2, 3? No, so these are called ordered pairs because the order matters, right? So that's what we mean by ordered pairs. It's pairs where the order matters. Okay, so now we've got these 2 words. Okay, now it's a set of ordered pairs, but what's a set? I didn't go into that, but I think you know sets. So it's a set of ordered pairs. So let me give you a set of ordered pairs. How about 2, 4? That's a pair. That's an ordered pair, right? So that's in. Let's suppose that's in my set. And let me give you another one. 3, 9. That's an ordered pair. So I'm going to put that in my set. And I'll give you another one. 10, 100. Okay? So is that a set of ordered pairs? Yeah, it's a set of ordered pairs. How many ordered pairs are there? 3. Okay? So I just said that this could, instead of this is a kind of definition of what I mean by function, but now I'm saying I could also define it this way. Why? Here's a set of ordered pairs. This defines a kind of a function. What it sort of is, it's obviously related to this function, right? It's not exactly the same, because the only inputs are what? 2, 3, and 10. Whereas here I just mean basically anything can be an input. Okay? But this is kind of like part of this function, right? Right? It's like 2 goes to 4, 3 goes to 9, and 10 goes to 100. So it's like, it's a function in the same way that this is, but the thing is, the only things that I'm allowed to put in here are what? What are the only first elements there? 2, 3, and 10. So 2 can go in there, 3 can go in there, and 10 can go in there. Okay? So in other words, how about this? Is this really a set of ordered pairs? Can we think of that as a set of ordered pairs? Yeah, it would be a huge set of ordered pairs, right? So I can't write all the ordered pairs, but can you give me a few of the ordered pairs that are in this function? Yeah, for example, what? 2, 4 is one of the ordered pairs in this function. Give me another one. What? 0, 0, okay. Give me another one. 5, 25, okay. Give me another one. How about a negative number? Minus 10, 100, right? And so on. So it's a big, infinite set of ordered pairs. However, this 3, 5, that's not in here, right? Okay? Okay? Right? But you can imagine many, many things that are in there. So we can call it, we can define a set, we can define a function as what? A set of ordered pairs. Okay? Any set of ordered pairs is a function. No, that's not true. Any set of ordered pairs is a function. That's not true. Why? Why not? Because I didn't finish my whole discussion of what I mean by a function. Do you remember, for example, that, I hope that you've seen this before actually, but do you remember that that is not a function or not? No? Then I have to remind you. How much time do I have? What time is it? I have 3 minutes. Why is this not called a function? Because there's a special rule. We don't want just any shape. So this, basically any shape is a function, but not really. There's one rule it has to satisfy. Do you remember that rule? What is it? If you take a vertical line, which way is vertical? Up and down or left to right? Which way is vertical? Up and down or left to right? Up and down. If I take a vertical line, vertical means 90 degrees, not slanted. Vertical line, if I can take a vertical line and cut it and hit that function in 2 places, then we don't call it a function. That's very arbitrary. Why did somebody say that? It's just kind of arbitrary. I could give you a reason, I could make up a reason. But since we only have 3 minutes, I won't bother with that part yet. But anyway, that's part of the definition of function. So you can't cut it in 2 places. Now, how does that relate to, how about this? So I want to use this definition also. But I need to have it agree with this definition. That is, that you can't cut it in 2 places with a vertical line. So how about this? If I give you this set of ordered pairs, 2, 8, 3, 7, 2, 1. Is that a function? It is a set of ordered pairs, right? And I said it has to be, I want it to be a set of ordered pairs, but that's not the end of the definition. You need to make sure that it doesn't do this. Okay? So how about this? This is a set of ordered pairs, but is it a function? Does it satisfy that green problem? This green problem here. Does it satisfy that or not? No. Why not? If I draw it, what do I get? 2, 8, right? That's 1 point. Okay, what else? 3 comma 7. It's another point. Right? And what else? 2 comma 1. Okay? That's the picture, right? That's the graph of this function, right? Okay? Now, does it satisfy the green situation? Is there any place where I can draw a green vertical line and cut it in 2 places or not? Well, it's not like, the question isn't, if I just draw an arbitrary green line, do I cut it in 2 places? That's not the question. It's, can I find a green line, a vertical line, that cuts it in 2 places? So if I just draw an arbitrary one, no, I didn't cut it in 2 places. In fact, it didn't even cut it in 1 place. But that's not the question. The question is what? Can I find a green line, a vertical line, that will cut it in 2 places? Yes or no? What? Yes, where? Which green line? The one that goes through 2, right? Goes through that. Well, didn't work, but you know what I mean, right? Here. Right? So, is this a function? No, why not? It is a set of ordered pairs, but that's not the full definition of function. The full definition of function is, it's a set of ordered pairs where this doesn't happen. How do I say that using this language? Can anybody say it or not? A little bit tricky to say it. How do I say that it's a set of ordered pairs? I have to give an extra clause to this definition. In other words, I want to say it's a set of ordered pairs such that, and then it's a little bit tricky to say it. Can anybody say it? A little tricky. Although it's obvious, right? The funny thing is that things that are like pretty obvious, when you try and say them kind of very precisely, becomes like a pain in the neck. It's not as easy as it seems. Anybody? But there's one way to say it. Probably other ways to say it too. Can anybody say it? So I want to say it's a